This is topic 7.2, direction of reversible reactions. So the objective today is to be able to explain the relationship between the direction in which a reversible reaction proceeds and the relative rates of the forward and reverse reactions. If this is a reversible chemical reaction, the reaction reached equilibrium, the rates are equal forward and reverse. However, if my rate forward, meaning left to right, is greater than the reverse, that means I'm going to have more products than reactants. The net gain in the amount of products will occur until it's at equilibrium, the reaction does, and the amounts of both reactants and products are going to be constant. Same thing, if I have a greater rate of my reverse reaction, that means I'm going to have more reactants than products. There's a net gain towards the reactants. The reaction N2 plus H2 producing NH3 is at equilibrium at 500 K. So this is a reversible reaction. What happens to the rates of the forward and reverse reactions if some NH3 are added to it at a specific time? So if I add more NH3, the rate of the reverse reaction will increase to establish equilibrium. The rate of the reverse reaction will be greater than the rate of the forward reaction until it reaches equilibrium. I know it looks like roaches, but it's reaches. So on this slide, I'm going to introduce something called an ice chart. So in a previously evacuated 1 liter flask, you have 0.40 moles of A and 0.50 moles of B. They're added and allowed to come to equilibrium. At equilibrium, there are 0.15 moles of C. The equation for the reaction is as follows. Sketch 3 curves below to show the reaction as it reaches equilibrium. So, because it's in 1 liter, we can assume that the moles are the molarity, so it's fine. So we have A, B, and C. We have our reaction here. A plus 2B produces C. And it's a reversible reaction. So to figure out what we're going to be at, we need to create something called an ice chart. So that stands for initial, change, and equilibrium. So we have A, 2B, and C. I want to make this color coded. So according to my problem, I am starting off with 0.40 moles of A. 2B, I'm starting off with 0.50 moles. So for C, it says that, well, it doesn't really say we're starting off with anything. That's what we end up with. So that means we're going to assume that we start off with 0, and we end up with 0.15, according to the problem. So for here, in order to figure out where we're at equilibrium, we got to figure out how much our reactants and products are changing. So, according to this, to change from the initial to the equilibrium, the C increased by 0.15. You'll see that it's going to be sort of the same thing on with the reactants, but because we're forming C, so we add it, we have to subtract by the same amount based on the number of moles. So for example, letter A, if it if C increased by 0.15 and it's 1 mole, since there's only 1 mole of A, we're going to assume that it decreases by the same amount in 1 mole. So at equilibrium, I'm 0.25 moles. For 2B, there's 2 moles of it, so that means that it decreased by 2 moles in this problem. So that means it's going to decrease by 0.15 times 2, so 0.30, so 0.20 moles is that will be at equilibrium. So how do we graph this? So letter A, we're going to start off at 0.40. It says that we reach equilibrium at some point at 2.5 moles. So let's try to find 2.5 moles. It doesn't really give specifics at what time, so I'm going to put it at a pretty neutral place, so right in the middle is okay. So that's going to be at equilibrium 0.25. I'm going to kind of just graph this, just curve it like that. Oops, ugly. There we go. So 2B starts at 0.50 and it reaches equilibrium at 0.20 moles. So it's about here, same time. So you'll notice that this is probably going to be, this is a steeper curve compared to the other one. Let's make it all look nice and neat. In green, so letter C, I start off at 0, and at equilibrium, I'm at 0.15 moles. So same time, we reach at equilibrium, put that there, and now you can see your products kind of come up from the bottom, assuming we're starting at 0. Oops. Make that look better, I guess. All right, that's it for this topic. If you have any questions, please let me know.